Welcome back, everybody, to a brand new unit. In this Unit 10, we are going to be exploring what we call sequences. Now, a sequence is a list of numbers that follow a specific pattern. So you might want to go ahead and write that down. A list of numbers that follow a pattern. Now, every day in this unit, you're going to be needing your graphing calculator as well as your note packet from class. All right, today we are going to be exploring our day one, okay, which is all going to be about the explicit formula of sequences. All right, so our goal for today, given a sequence written as an explicit formula, you will be able to write a list of the terms in the sequence and find any term in that sequence. So let's go ahead and get started. All right, so here we have a sequence. Now, a sequence is a list of numbers that follow a pattern, making it possible to predict the next number on the list by examining the numbers before. The pattern could be adding a number to the term before, multiplying a number to the term before, or something even more. A sequence is a new type of function. All right, so let's go ahead. Let's take a look at a few different sequences, and let's see if we can find the pattern. So our first sequence, so it says find the next three terms in each sequence. Our first sequence, 1, -3, 9, -27, and 81. So if I look carefully, I can tell I'm not adding a number to get to each one. In fact, if I look carefully, I can see I'm multiplying by -3. Multiplying by -3. And that's going to be my pattern. So I'm going to multiply by -3. So let's try to find the next three terms in this sequence. So I left off with 81, and then I'm going to multiply by -3. -243. Then I multiply again by -3. 729. Then I multiply that by -3. -2187. All right, let's take a look at the next sequence. 9, 109, 209, 309. Now it's pretty easy to see that all we're doing is we're adding 100 to each term. So let's write out the next three numbers. The next three numbers would be 409, 509, and 609. And I'm going to put that inside of my set notation. Let's take a look at the next one, 0 to 3 to 8 to 15 to 24. Now I can't multiply anything by 0 because I would just get 0, so I can't be multiplying. So let's take a look at adding. So from 0 to 3, I'm going to add 3. Then I'm going to add 5. Then we're going to add 7. Then we're going to add 9. So it looks like we found the pattern. So we're going to add the next odd number. So let's find the next three numbers here. So we left off with 24, okay, and we had added 9. So the next odd number is 11. That gives us 35. And then 35 plus 13 gives us 48. And then 48 plus 15 would give us 63. All right, and our last, we take a look. 4 to 16, okay, I'm not adding. Let's take a look, multiplying here and multiply by 4. Oh, nope, not multiplying. So let's try to find something different. So here, 4, 16, ooh, they're all perfect squares. So 4 is 2 squared, 4 squared, 6 squared, 8 squared, and 10 squared. So it looks like it's the even numbers squared. So let's find the next three numbers. So we had 10, so now we're going to go ahead and do 12 squared. We get 144. 14 squared, 196. And 16 squared, 256. All right, so that's a little practice just finding your different patterns. So now let's talk about how we actually write a sequence. So terms in a sequence. Each term in a sequence can be denoted by a sub n, where n equals the number of its order in the list. So what's very important here, order is important. Your sequences are in a special order. Okay, and the way we're going to write that out, so we have 2, 4, 6, 8, 10, 12. 2 is the first number in the list. So that's going to be denoted as a sub 1. This little 1 means it's the first term. All right, 4 stands for a sub 2. Now it's 2 because this is the second term in the list. 6 is a sub 3 because this is the third term in the list. So 8 is the fourth term, so that's a sub 4, a sub 5, a sub 6, which means this all the way out here would be a sub n. Because we don't know what it is, it would be your nth term, so it would be a sub n. All right, so let's go ahead and let's practice defining our different terms. So the sequence, given a sequence a sub n, find the value of each term below. A sub n equals 3, 5, 7, 9, 11, 13, 15. So 3 is the first number in the list, so this would be a sub 1. 5 is the second number, so this would be a sub 2. A sub 3, a sub 4, a sub 5, a sub 6, and this would be a with a little 7. So let's go ahead and answer the questions now. So a sub 4, so that means we want the fourth number in the list. So we're going to take a look, 1, 2, 3, 4. So that number is going to be 9. Okay, and then we take a look at B. We have a sub 1. And that's going to end up being the first term in your list, which will be 3. Now a sub 10, if you look, we only go to 7. So let's see if we can write the next 3 terms. So 15, 17, 19, 21. So that'll be 21. Now over here, we have the square root of a sub 4. So we're going to take the square root of the fourth term, which is going to be 9. So the square root of 9 equals 3. And we've got it. So next, it says solve for n if a sub n equals 13. So I'm going to look there, a sub n. So that means a sub 6 equals 13. So this is your n, so n equals 6. All right, so order is important. We make sure that we write out our list. A sub 1 is your first term. A sub 5 would be your fifth term. So now that we know how to find the pattern, we know how to denote. Oh, please go ahead and discard that message there. We know how to denote our different terms. Let's go ahead now and let's see how we can put this all together to actually come up with the pattern. So our explicit formula of a sequence, a formula that allows direct computation of any term for a sequence without having to know the term before it. It is also known as functional form. So here we have a sub n. This is just a fancy way of saying that it's a function. Similarly, we have f of x, which is just a fancy way of saying it's a function. And the same thing for y equals means it's a function. All right, so if we want to come up with a number of term in our list, so let's say they actually gave us a formula. So a sub n equals 2n plus 4. To find the first term, we're going to take that 1 and we're going to substitute it into the formula. To find the second term, we take a 2 and we plug it into the formula. 3, we plug in a 3, 4, we plug in a 4. This is very similar to when we learned our function form. When you have a 1 in the parentheses, this is the same thing as your x. So x we plug in over here, x. So 1, we're going to substitute in for 1. 2 for 2, 3 for 3, and 4 goes in for 4 to find the sequence. Now we can also do this in a table of values. Your y is actually going to be the sequence that we're looking for, and the x is going to be the number of the term. Okay, so let's put this all together. So your directions, use each explicit formula to find the first 3 terms in each sequence, starting with n equals 1. So here I have a sub n equals 4n minus 1. So if we notice, we have an n and we have an n. So I want to find the first 3 terms, starting with n equals 1. So I want a sub 1. So what I'm going to do is I'm going to rewrite this formula, but instead of an n, I'm going to put in a 4 or a 1. So 4 times 1 minus 1. So I substituted in this 1, and I put a 1 in for the n. So if I were to add that up, so 4 times 1 is 4 minus 1 is 3. And then a sub 2 equals 4. And this time I'm going to put 2 inside of the parentheses. So my 2 matches with the 2. All right, so 4 times 2 is 8. 8 minus 1 is 7. And then a sub 3, I'm going to substitute in a 3. All right, so I have a 3 here. and a 3 here. So 4 times 3 is 12, minus 1 is 11. So this is the first way that we can solve using our substitution. We can also use the calculator to help us out. So as a reminder, this is going to be your number of terms. So 1, 2, and 3. So this is the same thing as your n, and this would be your a sub n, similarly to your x and your y. So let's go ahead. We're going to go to our y equals, and let's type in this formula. So 4, now n is the same thing as x, so we type in x minus 1. I go to my table of values, and now I'm going to match it up. So 1, the y value is 3, 2, the y value is 7, and 3, the y value is 11, which means the first 3 terms in our sequence are 3, 7, 11. And we can write that as our set notation. All right, let's go ahead and try another sequence. So here we have a sub n equals 10 parentheses 1/2 all raised to the n minus 1. So here we have our n, and in the exponent we have our n. So let's go ahead and let's find our first term. So I'm going to plug in a 1 wherever I see an n. Okay, so here again, I match up my 1 with the n. So let's go ahead, we're going to go back to our main screen. Let's type this in. So 10 parentheses 1/2 raised to the 1 minus 1, which is the same thing as 0, and we get 10. Now we can try a sub 2. So 10 times 1/2 to the 2 minus 1. Again, your 2 matches with the 2. So let's plug it in. So 10, 1/2 raised to the 2 minus 1, and we get 5. And our third term, 10 times 1/2 raised to the 3 minus 1. Raised to the 3 minus 1. We get 2.5. Let's also try the calculator to see if we can match it up. So let's go to our y equals, this time 10, 1/2 raised to the n minus 1, or x minus 1. We go to our table of values, and let's see, 1 matches with 10, 2 matches with 5, and 3 matches with 2.5. And those are the same solutions we got when we use substitution. So our 3 numbers in the list are 10, 5, and 2.5. Okay, so now that we know that we can use substitution, let's try working on a different type of question. So let's take a look at number 5. The third term in a sequence is 10, and the fifth term is 26. If the first term is a sub 1, which is an equation for the nth term in the sequence? So now we want to find out which of these formulas will give us these stipulations. So let's go ahead and let's take a look at the information that they gave us. The third term is 10. So the third term is 10. Okay, and the fifth term is 26. So 5 and 26. So now let's use our calculators to see which one will give us these results. So I'm going to try the first equation first. So I go to y equals, and I type in 8n plus 10, and I go to my table of values. So we want to find 3 and 10. So if I go down to 3, the y value here is 34, so it can't be a. So now I'm going to try b. I go to y equals, so 8x minus 14. I go to my table of values. Let's take a look. 3, 10. That one works. 5, 26. So my answer is going to be B. All right, and our final question today, question 6. A theater has 35 seats in the first row. Each row has 4 more seats than the row before it. Which expression represents the number of seats in the nth row? Well, let's give ourselves a few pieces of data to work with before we start looking at the formulas. So the first row has 35 seats. The second row, okay, is going to have 4 more. So 35, 4 more would be 39. So the third row would have 4 more than that, which would be 43. So let's start plugging these in to see if we can match up. So let's go to y equals. I'm going to type in 35 plus parentheses n plus 4. And I'm going to go to my table of values. Let's see. So 1, 35 here, it's 1 and 40, so it can't be choice 1. All right, let's try B. So I go down 35 plus, and here we're going to go 4x. and I go to my table